Hello, hello, hello. Good evening, guys. How are we all? No, we do welcome you guys to the May edition of the AWS and the user group. We've got some cracking topics to go for today and some cracking speakers on board with us today. Quickly, let me jump into the agenda. So, first off, we'll be talking about mastering containers and scaling on AWS through the power of EKS. So Asif Khan, who is an enterprise solutions architect, he'll be taking us through some of the techniques of, believe it or not, like 80% of the techniques which he's going to be talking about is being used in the AWS atmosphere and through the customers as well. So, and simultaneously I'll be handing it over to Jonathan. Now, Jonathan Lim is a senior SA. He's graced us from Singapore, to be honest with you. He's come up here to present with us. So he's going to be talking about some of the optimization techniques in DevSecOps lifecycle. So that is pretty interesting. And to end the night, we'll be ending it with some food, and we've got some pizzas and beers coming up for you along with the networking session. And I really wanted to give a special shout out to GitLab for supporting us with food and drinks. We really do appreciate it, and thank you on behalf of Polar 7. We appreciate it. Okay, without further ado, I will give the podium to Asif, if you don't mind. Let's do this.
Presenting itself is so challenging and you're asking to hold it.
Well, whatever is convenient to you, I guess.
Okay, thanks. Sorry, what? I think so. Oh, we have people through there.
Yeah, it's going to be probably packed because a lot of people are coming in as well. So.
Can you hear me? Yep. Seriously, it feels like Colosseum, like gladiators. You see people. I hope I don't die today over here. But anyways, thanks a lot for joining in. People are still coming in, maybe we'll give them some space. Oh, sorry. Yeah, no, go for it. How are you? Hopefully that's it. All right, so I'm Asif. I'm a senior solution architect at AWS. I work with the enterprise team, mostly in the retail space. So what I do in my day in, day out, I work with customers on different AWS services, helping them on their journey for enablement in the cloud space. What that technically means, I too don't know. But yeah, at the end of the day, I solve customer problems, and that's what I love about the job. What I've done in the past, I have worked with other enterprises as well, like PwC, Deloitte, and previous to this, most of my friends and colleagues at AWS don't like it, but I have worked with Microsoft as well. I was a cloud solution architect over there. So I have been playing around with containers for almost 3 to 4 years now. Back in time, I was doing mostly around Azure. So it was Azure ACS and Azure Kubernetes Service. Now it's EKS. The beauty about this entire transition was that I never felt that I was doing a transition. Everything was to Kubernetes. So that's why I love this particular platform. It's equalizer sort of model. So irrespective to where you come from, it will be the same whether you go GKS, EKS, AKS, all almost the same. But we have differentiating factors in EKS in contrast to what AKS does, in contrast to what GKS does. So that's my QR code. If anyone interested, if not, that's fine, forget about it. Just give me a shout. I'm more than happy to help assist in any of these companies if you're interested in. I can recommend or maybe whatever help you want, more than happy to help with that. So what are we going to talk today? We will talk about containers and security, and we will be talking about scaling. Now, security, because it's the talk of the town, everyone wants to talk about security, and there's nothing wrong in it. Fundamentally, if you are not secure, we have already seen the events which have happened with different providers in the retail space and other spaces as well. So yeah, security should be a very important aspect when you're designing things. And at AWS, we call it as job zero. So even before you start anything, security should be your consideration. So these are the agenda. It's pretty skimmed. The reason it's skimmed is because organizers, when I had the discussion with them, they said we have only 30 minutes. I might be running through in order to complete all the content. But if you want to stop me anywhere and if you have any specific questions, just give me a shout. There's no mandate to complete all the content which I'm here to present. But yeah, feel free to give me a shout and ask for any questions if you have. I'll try to answer them. Maybe I won't be knowing it. I can connect back and get you the answers. So we will be covering about AWS container services, which includes EKS and EKS, ECS, Fargate, and App Runner. So it's and what I'll be doing is I'll be giving you the journey, how exactly we started, what's the temperament and things around it. On the second agenda would be around the security of these different services, and last will be auto scaling side of things, how we auto scale in EKS world, different components involved in that. So before we start, I think it would be good to understand the demographics over here. How many of us have used containers in production? God have mercy on you. And how many of us have been playing around with containers? Okay, that's good. That's good. So in a general note, like what was the experience like running things in production or on the container side? Or what was it? What were you using? Anyone?
ECS.
ECS? Oh, nice. Any challenges, experiences, bad experiences, burning midnight oil?
Nothing like that.
Oh, wow. Lucky one. All good. Bad documentation. Totally agree with that. Yeah. Anything else? Any more critics? Because that's what I'm here for. Perfect. I'll feed that back. Don't worry.
Yeah, we do use EKS, but
Mhm.
sometimes some of the GPU support is not there.
Okay.
Yeah.
Yeah. I think I'll check that. I am not aware of across it because my understanding was for all the different instance types, we are very much evolved and supporting all these. But yeah, definitely I'll feedback. All right, so we have limited time. Sorry, I can't go for a long chat. More than happy to have these chat after this. But yeah, so if you look at the evolution of AWS container services, and not only container, overall compute services. So we started in 2006 from EC2s, went into Elastic Beanstalk for the management services, management model concept, and then it went into ECS, it went into Fargate and App Runner. All these are evolution, and we will be talking about these in detail in a later stage. So under the hood, it goes in this dimension. So everything was inherited. So ECS was the reason why we got Fargate. Fargate was the reason why we got App Runner, and it's all evolution on top of each other. So let's start with the fundamental. If we talk about a web application, what exactly we have? We have a virtual machine running on a bare metal or something. We basically put an operating system on top of it. Next we put a language runtime, whatever it can be, Java, .NET, or whatever you use. And then on top of it you put your application. And that's how, in a normal world, web application works. You can have different tweaks at places, but that's normal. What do? In order to bring resilience and availability, you put multiple of those. Then you put a load balancer to basically support that, and then you put auto scaling on top of it, and that's how you are able to support it. Now, and then you put a CI/CD. It's not only putting a DevOps implementation on your instances, but also on top of your application as well. Now, if we talk into the EC2 space, how this container evolution happens. So we have this physical servers. Obviously, even in cloud, somebody would be running some server somewhere. And then on top of it, we have these EC2 instances where we have this application as well as the operating system and everything. Now, we have similar load balancer, DevOps cycles, and stuff like that. The thing which you look at over here is the load is mostly on the customer, because anything in gray is what AWS is supporting, and everything beyond that is supported by the customer. And this line is what we are trying to push as much as possible on the upper side. So what that led to is in 2006 we came up with EC2, and then we came up with the container orchestration, which was up top of the town in 2013 and stuff around that. So what we did, we provided EC2s, and you can, instead of running your application directly, you can put something like a container runtime, containerd, or you can use Docker Swarm. In the past there used to be Docker Swarm, and there are a couple of other runtimes which you can use. On top of it, you can still run your application, and then you can have multiple of these, which will basically give you the similar experience like EC2. Container runtime, again, was pretty good. Scaling was fine, but again, how to manage it? That led to the concept of, okay, we should have something like a container orchestration system with a control plane, and then you have your container orchestration agents which will be supporting your containers. So this was the EC2 world. We came into the ECS world. Now, in the ECS world, what we did was we brought the line up. So we brought in, so in the ECS, what we did was we brought in the container orchestration control plane into our management side. So now you still have everything, but container orchestration is managed by us. Now this was still good, but not good enough, because as a customer, we heard that customers were having a lot of time invested in managing these environments. So as a customer, you should be focused more on your business side of things, business application and stuff. So this was ECS with control plane, and you have your agents installed on these EC2s. Same CI/CD, load balancers. Now in the Fargate environment, what we did was we still had the container orchestration, but we brought the line up. So now it's getting more into the management side of things. So all these grays are what is managed by AWS, and anything in the amber ones is managed by as a customer. Load balancer, application, language, runtimes. Now this becomes a little bit leaner for you, because now you are having less loading management side of things. Obviously, deployment and load balancing is what still the customer is managing. Now this was 2017. Now in 2021, we came up with App Runner. So App Runner is again pushing the boundaries, and what we are doing is we are pushing it a level up. So the entire AWS management side of story increases. Now we are even managing the language runtimes, because at the end of the day, if you would have used App Runner, what you do is you provide a Git repository endpoint to App Runner, and from there it manages creating the build, creating the image, deploying the image into App Runner environment. And App Runner itself is nothing apart from a Fargate abstraction. So you're still, the containers are running in Fargate, but it's just abstracted from you, and you just provide the code base, and rest everything is done by AWS. So that's a pretty much a journey of what has happened from stages to stages. We didn't cover anything around EKS. The reason being is because EKS is bare metal, whatever was built by Kubernetes. We have just added components on the control plane. So the evolution is not as interesting as what we saw over here. But in our space, in EKS, we have the control plane, which is much more enhanced and qualified compared to other providers. And what we have recently seen is around 60 to 80% of the containers in the entire global ecosystem are running on AWS. So yeah, it's maturing. We are finding issues on the fly, and then we are fixing it as well. So that goes into the AWS runtime. app runner space. Now, everything has to run on some place. Now, in a conventional world, it's running on EC2s. In other cloud, you will be running on their own virtual machines. Now, what we have in AWS is something called as Firecracker. Firecracker is a proprietary technology which was built by AWS, and this is the holy grail on top of it. All the containers, and if you would have used Lambdas, they are all running on this. The reason why we went in the dimension of creating these different specific virtual machine types. So if you look at a conventional virtual machine, normally you would have experienced it takes somewhere around like 60 seconds to 2 minutes, depending on which cloud provider you're using or which instance or environment you're using. It takes to boot up and be available for deploying your application. That was not good enough if you are talking about Lambdas, if you're talking about something which has to run in micro or milliseconds. So that's why Firecracker came into the picture. Under the hood, it still runs on a bare metal. So there is a bare metal, there is a host operating system, but on top of it, there is a Firecracker virtualization environment. So we don't have any hypervisors. It's Firecracker, which is basically doing the entire kernel level to the operating system, that everything is engrossed into the Firecracker itself. Now what you do is, it has the uniqueness of being a virtual machine, but not realistically a very conventional virtual machine, because it is skimmed to align with the container ecosystem, and anything which is needed by the container is only what is available over here. It doesn't carry anything beyond that to be heavy. Now, that was a differentiator. What is common like a virtual machine? So in a virtual machine, like you can separate out your application, you can have the isolation boundaries by creating multiple virtual machines. Similar is the construct over here. So you can have multiple of these instances. The only interesting bit about this is they basically turn on and they are operational in milliseconds, or if not milliseconds, then less than a second. So they are pretty quick, and that's why it's very useful in respect to usage with things like Fargate, things like Lambdas. So this has been totally supporting all of that till date. Any questions till now? Sorry, I'm filling up pretty quick because there's only limited time we have, but yeah, give me a shout if you have any questions. Now this is the interesting bit about security. So if we talk about the main component which we have in AWS and highly used is ECS. So ECS control plane is the most popular one because it supports Fargate as well as EC2 based implementation. Now how exactly a particular ECS, whether you are using EC2 or Fargate, does communicate with your ECS ecosystem? So what it has is, it has this agent communication service. Now this agent communication service basically is directly hooked to Fargate. We are pretty confident that there are no malicious activity which happen in the middle. So yeah, because Fargate is ours, ECS control plane is ours, and that's why it's pretty much secure. Now the challenge comes when we talk about the EC2 based implementations, because in the EC2 based implementation of ECS, this is customer machines. Now one part of the story is they have these ECS agents, but on top of it, customer can install anything. It can be any open source software, it can be their custom software, and then on top of it, ECS agent itself is open source. So you can go and tweak it, and you can create malicious vulnerabilities inside your EC2 instances. So what we do is, in order to secure it, we basically use instance roles and stuff like that, which basically restricts this particular ECS agent to access anything beyond its account. And that's why that is how the security of this is implemented. ECS is implemented through the control plane. Now the other entry point is basically the front-end service. Now front-end service is where you talk with your API. So using AWS CLI, or if you're using CDK, either of or any of the communication channel which you use to deploy a container in ECS, it talks to the front-end service. And that the way how we secure it is, it again goes with the same model. So we use IAM authentication and we use throttling and things like that in order to restrict that you don't bombard it and bring it down. And this is the highest level abstraction I'm talking about. The way how we are making it available and secure is by distributing a different availability zone globally, and then on top of it. So when you make a request in Australia, it goes to the closest data center. It can be Sydney or Melbourne. If you go with change in geography, it will be aligned accordingly. So coming into the app runner, we'll go into the Fargate next. But app runner, because there are bits and pieces which align with app runner and goes into the Fargate side of story as well. So if you talk about the app runner, we have different containers which are running. Again, these are all running on Firecracker because this is app runner itself doesn't have an environment, it's all running on Fargate. So these containers are individual Firecracker instances, virtual machines, and they have their own ENIs, so primary networking interfaces. And the way how we secure it is, no one instance is able to talk to another instance. So whether it's horizontal, like east-west or north-south, you can't talk to each other because there's no reason why you should talk to each other. The way you can talk to each other is only through this layer 7 communication. So all the traffic coming in, or even the traffic between the containers, which you are running in your app runner environment, they are all communicating through the channel of your NLB or load balancer which you're using. The way how this instance would be talking to your components or different environments or your different databases in your backend, which might be in your VPC or in AWS environments, or SaaS services, which like that is through the secondary ENI. So there is one secondary ENI which is hooked to your instance, the Firecracker VM. Primary is connected to the control plane, but the secondary is what you can connect to your different databases or different instances which you want your application to talk to. So that's how secondary ENI is. So recently there is also, you can have a total private communication channel between these app runner instances and your consumers, which might be enterprise consumers. So in that case, you can use private link, and that builds a dedicated connection. Instead of going through a public DNS, you can build that private channel, and that's how you can make it more secure. Now coming into the Fargate side of the story, it evolves from the same app runner construct. It has these firecrackers because each, as I said, each of these components which are on the app runner side are running inside a firecracker VM. Now again, similar model, we don't let two virtual machine firecracker VMs to talk to each other because there's no good reason why you should do that. And the only way they talk to outside world is through the EKS control plane. So all the communication channel goes to the control plane, and from there you can basically pull data or push data, or you can upgrade and things like that. Within the environment itself, if there are multiple pods, multiple containers, each container is running within its own virtual machine of Firecracker VM, and they are not allowed to talk to each other. So there is no there's a total restriction so that we have a limited blast radius. When we talk about if something is compromised inside your environment, that particular container will not impact any other container running on the entire Fargate environment. So that's why there is a limitation that's not allowed to have that communication channel between each other. So that restricts pretty much on the different layer. We also use the security group construct in order to restrict the traffic, whatever traffic we want to flow between different components, even if it is coming from outside through the control plane, we restrict that through the security group construct. And this is a multi-tenant, as you all know, so that makes it seriously complicated because there are banking customers who might be running this. You might be running your own POCs as well, and everything is running in the same space. So you have to have that level of isolation between different instances, otherwise things can get really worse very quick. Now coming to the EKS ecosystem, on the security side, all the things which are in purple, they are all pretty much supported by AWS. All the control plane is basically managed by AWS. All the data plane is normally managed by the customer. If you see on the lower side, the operating system, kubelet, CRI, AMI, these are somewhat shared scenario. So it means that you can bring in your own AMIs, you can bring in your own specific CRIs, if you want to basically customize it. But if we go into the next model, which is more on the Fargate side, now it's pretty fully managed. So what you do is you get an option for the horizontal pod auto scaling, vertical pod auto scaling. You get options for your pod security and stuff, but anything apart from that is pretty much managed for you. Now, whether does this support, is it every form of this is useful for every customer? No. It is very specific that you have to identify what's your business case, and based on that, we recommend that whether you should go with Fargate or whether you should go with self-managed EKS, or you should go with a managed EKS. All depending on your use cases, and that's basically the quantifying factor how we define which different particular persona of EKS you should use in your environment. So coming into the auto scaling side of things, So how many of us have we used EKS in production? Kubernetes in production? Okay. And so what are the experiences like? How much effort does it take to manage the scaling constructs in EKS, in whether you're using Kubernetes or EKS? Oh, it's, okay. Did it work? Okay, and how about like what was the scale at which you managed it? Like what was the incoming request capacity and things like that? Ballpark. A lot. Okay. Makes sense. So yeah, in a general note, there are a couple of different ways how scaling works in EKS. Not EKS, but in Kubernetes ecosystem. So the constructs which I am showing over here are generic constructs. It is a Kubernetes construct. Horizontal pod auto scaling and vertical pod auto scaling. Horizontal is when you basically create more of your container instances in order to support more traffic and things like that. And vertical is when you increase the size. So let's say if you initially created a container of 2 gig memory and of that capacity, and then you want to increase the size because your application new version needs more capacity, so you can scale out. Now the way how it happens is there is a model of graceful exit, so the initial running containers are drained out and then new instances are created for vertical pod scaling. On the horizontal, it's just it creates the similar instances based on your deployment file which you have provided. Now what we have is this is a proprietary product which AWS built. It's called Carpenter. So there is a concept of cluster auto scaling as well in Kubernetes. Now cluster auto scaling is one part of the story of scaling is you increase the number of pods or you make them of bigger size. But there is limit to amount of pods or containers which you can run in a particular instance. So how would you manage if your instance capacity has reached the maximum threshold? So let's take an example. If we have R5 instance and let's hypothetical that can run maybe 200 containers, and your scaling is still continuing, and you went to a point where your containers are now pending state because 200 is already reached. So the only option is you do cluster auto scaling. So that means new instances of your virtual machine environment is created, and then all the basic Kubernetes construct like kubelets, like your container runtime, are installed on your new instances which are provisioned. Now, that is a conventional construct of cluster auto scaling. What Carpenter does is it doesn't bother with Kubernetes cluster auto scaler. It is a total separate instance which runs on a CRD construct. Now what that means is, if you have used EKS, there is a concept of node group. So in the node group you define an instance type, and that instance type is what it will be created when a cluster auto scaling activity happens. Now that is very limited because if you have taken a specific instance type in the very beginning, then that will only change in increase the size, increase the number of those instances of that type. But let's take your application changed, and now instead of using a regular general purpose instance, now you need a high compute instance, or let's take you are doing some machine learning algorithm on top, and then you want an instance of that type. So that's where Carpenter comes in picture and makes things much easier, because it looks at your config file which you are providing, and it defines what instance type it will be provisioning. Now, it's not out of the world, it will select anything and do it, because when we have the CRD, this is where we define what are the instance type which are allowed. So you can define that, okay, instance type of this size or capacity is allowed. And there are a lot of different configurations which are possible in the CRDs. Now, this is outside the AWS world. Has anyone heard about KEDA? No? So, sorry. So KEDA is basically Kubernetes event-driven autoscaler. This is basically an incubator product which was later given to CNCF, Cloud Native Computing Foundation. And what this does is, normally when we talk about horizontal pod autoscaling, the pod autoscaling is dependent on something like telemetries or monitoring constructs which are coming out in CloudWatch. And your monitoring is, your Kubernetes environment will be checking that, okay, is there a requirement for more pods because the traffic has increased or my CPU utilization has gone high, it will create more pods. But not always will be the situation where you will have such scenario. Let's take an example, and let's go in the example side. So let's take this is a simple example. We have a credit card transaction in a normal world. It's going through your SQS, and from the SQS it goes into your existing capacity, that processes it, puts into a DynamoDB and sends it to the bank for processing. Now, what happens is if this scales to a higher limit, it will still go to your SQS queue, but your SQS queue will start to choke now. And the reason why it's choking is because the number of incoming requests are gone high, pretty high. So what happens in this situation is, if you go with regular metrics-based scaling, the SQS is still doing nothing, having just a choke queue, and your processing layer, which is your two of these existing capacity instances, they are taking the message from the queue and they are processing it. So there is no CPU bump, there is no capacity utilization increase. So there is no reason why Kubernetes environment or EKS will go and put more pods. So this is where KDAG comes into the picture, because it can go at different component level, and the component what I'm referring to are any of these components which you're seeing on the screen, and I'm pretty sure most of you would have used most of these components while building your solutions. Any of these can be used as the trigger for your scaling or adding more pods into your environment. So what happens is, this is a SQS example. It can be a Kafka, it can be a DynamoDB stream, it can be a DynamoDB instance, either of that. And what happens is, it basically comes in, pitches in, it sees that the queue is now being choked, it will start to create more pods, and there will be a lot of pods in the pending state. Now, because there are a lot of pods in the pending state, that triggers Carpenter, because Carpenter looks after if there are pods in the pending state. And what Carpenter will do is, it will start to provision more instances. And that instances will then start to consume the messages on a high capacity, and that would basically help in reducing your SQS queue, which was initially choked. So this is a pretty much a very simple example, but in an enterprise scenario, you might have much more complex situations. So what I have next is, I have a very, just a demo version of what exactly this architecture looks like. I hope this runs. Yeah, maybe. I can't see how to mute it, because otherwise two of me will talk. So what this does is, shit happens. It will be easy if I put YouTube over here instead of trying to run this. It's not taking in, I don't know why. Maybe I'll go back. Yeah, it's running, but I need to just mute it maybe. This was oh yeah, that's a good one. Yeah, let's run it away. Yeah. Some of the business. Yep, thank you. That's good. I'm just yep. I think we can remove it from the. Okay.
No, I think that the one which I
let's just put it on a normal without presentation mode. I think so that will be easy. Yeah. This was the most interesting part of this session. Yeah, it just died. It took me a while to build this. Hopefully this runs. Yeah. So can you see it? Is it visible?
Yes.
Huh? Okay. Maybe should I open it in YouTube? Yeah, that's better. Okay. Can you see it?
I'll try for an SLA.
So this solution which I just showed you, I tried to mimic it around using the real components. So on the screen, what you see on the left side is these are my nodes, and on the right side on the top is my pod. And there is one pod at this stage which is serving the incoming messages in the SQS. Over here in the left bottom corner, I have a script which basically pumps a lot of message in the SQS queue. And this is my CloudWatch dashboard. It would basically show that number of messages in the queue and the CPU utilization. So the intent is that even your particular container is not getting over-consumed by these messages. Still the scaling will happen because Carpenter will not bother to wait for burnout on the container level, and it will start to scale. So once I start to pump messages, once I start to pump messages, as you can see now, the containers have started to create. And this is all driven based on the number of messages in the queue. So I can define if there are 5 messages or more, then start to create more instances till you reach a point where you see less than 5 messages in the queue pending for processing. So it goes on scaling, and then at the same time, what you can see on the screen left side is my instances are also experiencing the number of pod increase. So at this stage, you can see there are new instances. So till this point, when the new container were created, that was the time when KEDA was working, because it was creating more containers so that it can pull out more messages from the queue. But on the left side, these instances are created because now I have a couple of containers in the pending state. So Carpenter came into the picture and it started to create new instances so that the pending containers can be processed and provisioned, and they can be initiated in these new instances which are added to the cluster. So what happens is eventually it all gets processed, and hopefully, I'm sure because it's a video. So all the instances, containers are getting terminated now, and once the container are basically gone, so now all the containers are totally, like, it's clear, it's back to its original state of a container instance. And I can, on the left side, I have these still couple of instances which are running, which eventually Carpenter will start to decommission them, and as you can see now, it's reducing. So the benefit about this entire solution is that without even you attending and putting more instances, and then in order to do cost optimization, just shutting them down at the right time, this is all done by the Carpenter and KEDA in conjunction with each other, so that you don't have to bother in the middle of the night to go and scale all things out. It's pretty lean solution, and it works pretty well. I have a customer who is running a betting application on top of it, because we all know that during Melbourne Cup and different carnivals, people get mad and they start to pump a lot of bets on different horses and stuff. And then at that time, most of the systems, they had to either manually auto scale. There are war rooms which are normally created in order to support such events. So things like these, components like these would be really helpful. So pretty much that's it, what I had for today's session. Sorry for the hiccup. Some things not always work as you want, but yeah, I think we ended up, hopefully this was good. This is the QR code if you want to connect, but anything you want to talk about, more than happy to have a chat. Thank you very much, and feel free to ask me any questions if you have.
Hello, everybody. Oh, there's a question. There's a question.
Oh, okay.
Is there anything similar schedule that we can use for ECS Fargate?
Sorry, was that?
For ECS Fargate, can we use SCADA, or is that?
No. So SCADA is a Kubernetes component. So it runs on a CRD model. So custom resource definition. So in Fargate or ECS, we don't have that provisioning option. So obviously it can't be done. But yeah, it's a pure Kubernetes component. Irrespective to whichever version of Kubernetes you're running or wherever you're running, you can use SCADA for that.
We will, just in the essence of time, we'll just pause the questions until the end of the session. I'll just hand it over to GitLab now.
Thanks. Okay, hi everybody, my name's Andrew. I'm GitLab, not GitHub. Just pointing that out, just so you don't know the logo. We're the snacky thing, so everyone knows who they're talking to. So Jonathan is going to talk about DevOps best practices with AWS, and we're going to talk about important things today about security. That's the most important thing that lots of organizations are thinking about. Now, we want you to be engaged, so everybody stand up. Come on, let's stretch those legs. I saw a few yawns. Stretch your hands, put your hands up. That's good, thank you. You can all sit down, that's good. Just want to get you engaged and excited. Now, Jonathan's going to talk you through the presentation. We're going to keep it nice and concise. We want lots of participation. We want audience to come back with some questions. And I think we've got about 8 or 9 pieces of swag. GitLab swag, which is high value swag, t-shirts and caps. So at the end of the presentation, feel free to throw some questions out and we'll give you some swag. All right, guys? So thank you very much. Hopefully this will be interesting, exciting. Please be engaged. Over to you, Jonathan.
Thank you so much. Hi, everyone. My name is Jonathan, and I'm a solution architect with GitLab. And I'm based out in Singapore, so I actually flew in this morning at about 6 a.m. So, if I start to slur or anything like that, please, give me a break. Yeah, I'm doing my best right now. So today I'm just going to talk a little bit about DevSecOps with AWS and how we have certain best practices and how, as technology partners, we work together to make some of these things happen. Right, so a bit of background about myself. I've been in the open source space for a little bit, working on stuff like SIEM solutions, machine learning, stuff like to do with log monitoring, Elasticsearch sort of type of things, and then also from monitoring like CloudWatch and other things like that. So after kind of being in many war rooms and everything like that, I did realize that there were a lot of problems that I think could have been solved earlier in the life cycle when you're developing the products earlier. And I thought that some of these things, I could learn from, and that's why I ended up at GitLab. Because what we do at GitLab is that during the development phase, when you're developing products, we want that to be a bit cleaner in that sense. Understanding the topic, and I think from AWS, just a show of hands, any of you guys here or ladies here are developers? Okay, oh, that's quite a lot. Yeah, that's good. Then maybe a little bit more, anyone DevOps engineer? Oh, okay. Well, still quite a lot. Okay. That'll be good. So, then most importantly, does anyone know GitLab? Right. If not, the door's that way. But no. So today I just want to give a bit of an introduction, and this slide is something that I think it's something many people have seen. Over the past few years or so, we have seen quite a lot of vulnerabilities and a lot of applications being exposed. And earlier we talked a bit about everyone's talking about security, so I jumped on the bandwagon because I had nothing else to talk about. So today I'm going to be talking about security as well. But it is becoming more and more, I wouldn't say easy, but there are more vectors of exploitations for applications these days. From the very simple reasons that, first and foremost, most developers today just do a copy and paste of code. We are using a lot of things such as, we look at Copilot, we look at a lot of code completion tools out there, and these sort of things could potentially, I'm not saying they will, but potentially also include a lot of these vulnerabilities with it. We rely heavily on libraries and dependencies these days. So that's something that we have to take a look at as well. All right, so through this presentation, I want to bring you through sort of an analogy. So if you don't remember anything, just remember this. So who here likes security checks at the airport? I didn't expect. If any one of you does, we need a chat after this. Right. So the idea behind it is that security checks can be painful, but I think if we travel over the last 10 to 20 years or so, we did see that there are things that are being improved over time. Right. Seem like one single scanner sufficient today? Right.
No.
Okay, great. Yeah, I can't give t-shirts to everybody, but yes, it's not sufficient. I mean, if you go through a scanner today, sometimes at certain airports you'll see some dog sniffers. Even if you go through a metal scanner, there are lots of things that people can do today that are not metallic in nature. And even more so is that you do, I'm not sure about Australia, I haven't been to Australia, this is my first time in 5 years by the way. So, but for example at the Singapore airport, so they do multiple rounds of scanning. So like when you show your passport at the first entry gate, they scan it one time, they do it at another time when you actually, before you board the plane, right? So there's a couple of ways of scanning. Same likewise when you're scanning code, right? I think it's very important for you to scan all your code, not leave out as different components, but at the same time, every time a commit is done, every time you write certain lines of code, scanning should happen. Because first and foremost, that makes things a bit easier. You get to sieve out a lot of the problems early on in the development phase, rather than only just before you board the plane, which is when you deploy into production. So some of these things I think are very, very important. Right. So with regards to security, security is a very big topic, and there's probably 1,000 companies out there that are in the space of security. And where GitLab and a lot of like application security vendors today, we only are in this component of application security, right? So of course with like AWS here today, there's like things such as things that you can actually do, like of course monitoring and observability. But for example, from your WAF standpoint, how do you actually block incoming traffics and all that? I'm not an expert in all of these other components, but I just want to kind of like remind you that security is something that you have to look at in totality. You cannot just look at a single thing. So one security scan, that's definitely not good enough when it comes to making sure that your application is well and secure. So with GitLab, some of the things that we want to look at is your SAS testing, right? So your static application security tests, DAS testing, which is your dynamic testing, dependency scanning, or some people see in this sense of dependency scanning plus SAS testing as SEA, or software composition analysis, as well as container scanning, right? So the topic of today with containers, when you're using a lot of, you're using AWS, you're using your EKS or so, what are you doing to ensure that your containers are being secured in that sense? Fast testing is also very important. I think working with a lot of FSI customers in the region, in Southeast Asia, mostly, that's also something that's very important. So what is fast testing, right? So in short, fast testing is you're trying to break the system by adding additional parameters to maybe say for example an API to see whether you break the API or not. Because you, as a developer, maybe you don't catch certain types of regex patterns or anything like that, or you don't do proper validations also, right? So some of these things are very important because you don't want your banking application to go down. For example, right? Not saying that banking is the most important, but it is. Infrastructure as code. I'm just joking, by the way. But infrastructure as code, today, I mean, if you're using AWS, that's something that I think is very important. And I have a slide later about some of the things that you could do with AWS as well as some of the infrastructure as code scanning that we do have inbuilt within GitLab today. Secret detection. Okay, this one I'm curious about. Has anyone mistakenly put their AWS key into the source code? Right. Thanks for being so honest. So I think this is something that's actually really common, right? So I think there were 2 hands up there, but I'm pretty sure that there were more just liars. Yeah, exactly right, liars. But it's very common, right? And most of the time, I don't think people are malicious about it, right? It's just usually the case when if you're doing a development branch, you're developing in a certain way, you hard code it because it doesn't matter at that point in time. But when you promote it to like a different environment, like a UAT environment, a SIT environment, or production environment, sometimes you forget and you leave it in the code and you don't catch it. So secret detection in this case becomes a very important component, not only just for your AWS keys, but other components of keys or certain types of regex patterns that could be vulnerable or confidential to your organization. These are things that you should take note of. Right. So when should these tests run? Right. So we have here 9 different types of tests that I mentioned in the previous slide, and majority of the tests can run before anything is done. Right. So usually, statically, you have the code that's inside your source code management tool, something like a GitLab, something like a GitHub, or a Bitbucket. you can actually run a lot of these tests already. The only one that you do have, of course, is a review component about it. That means you need an application that is running before you can do your test. And that's where, using like ECS, EKS, AWS resources for you to actually build these things, and also not just build it, but also be able to, pull it out and destroy it quickly is very important in this kind of case. I highlighted infrastructure as code scanning because in this case, I just want to highlight that with GitLab, we have our own infrastructure as code scanning. What we do leverage on is KICS, like KICS. Does anyone use KICS, by the way, in your infrastructure as code scanning? I see some hands up there. But at the same time, I think if you're using a lot of AWS resources, CloudFormation as well, so they with AWS, they also have certain types of scanners specifically for CloudFormation tools. Correct. So one example is, first and foremost, leveraging on existing GitLab templates. So you can see here that just by using certain types of templates, you would have your code quality, your container scanning, your dependency scannings, and so on and so forth. And integrating like CloudFormation. So I think if you look at this GitHub project over here, AWS CloudFormation, it gives you a little bit of idea about what it does. It is, I think, maintained by AWS as well, and you can actually, it's not only just like a fixed thing, right? So if you read the documentation, you can actually come up with policies around your organization, so not just like the default ones. Of course, there are default templates and rules available today already, but you can also customize it in a way that is suitable for your organization. And what this does is that you can see certain things like maybe privilege, whether you're giving that level of privilege to your containers and so on and so forth, and all that. And this is something like that. Right. So if we have a bit of time later, we can kind of look through it, an example. But I think for the sake of time, let me move on first. But this is an example of how you can actually pull it into a GitLab template or a GitLab CI file, which is where we do our CI/CD, and how you can actually use CloudFormation Guard in your workflow. Right. I'll leave the questions for later, but if you have something burning, just raise it up, and I'll probably address it later as well. Okay. All right. So first and foremost, we looked at whether one security scan is good enough, or when you go through your security scanners is good enough. Second thing is, can my officers make informed decisions, right? So if we go to the airport today, you walk through a security scan, there are still officers there making sure that everything is fine, and everything, they look through your baggage, they still have to check it out. It's still not AI assisted yet. I don't know when that will be, now the decision makers, the ones who let you go into the airport also, are still human and decision makers. And what is most important about these decision makers, you don't want their lives to be hard. All right, you want the information that is concise, simple, and easy for them to understand, so they can push the jobs along quickly. So to understand it from a workflow perspective, this is how it works in a GitLab way. Not really a GitLab way, but in a trunk-based kind of methodology. So say, for example, you start out with an issue where you have a story or something like that, and then you get assigned an issue, a developer gets assigned it, you come up with a feature branch. With that, you push your code, and that's where your automated testing occurs as well. So over here, you have your unit tests, you have your performance tests, you have your different types of tests, your browser tests, and so on and so forth. Security scanners will also happen in this phase, and you get your results automatically. So you can see that that's that sign over here, because it's every time you commit, you get a result, and then once you get the result, you see what vulnerabilities you have, you fix it immediately, you don't wait until it's later, and then you do that process until it's clean. After that, once you are pretty good with it, you can deploy it to like a AWS resource over here, whether is it your EKS, ECS, whatever that is on AWS today. And why is that really important today is because you want to be able to not only just stand up your environment, but also tear it down as fast as possible with the least amount of cost as possible, right? You don't want to be having something that's running there forever. Right, you push all these fixes, and the next component of it is, of course, you have your desk scanning, because now you have a readily available portion, and all of these different types of tests. I talked about 9 different types of security scan. I haven't talked about my code quality. I haven't talked about my, my performance test. Can you imagine a developer or team lead having to deal with that much information and having to go into multiple different tools to actually make sure that all these things are fine? It's quite a bit of a headache, right? So this whole component about it is where I think with GitLab, we want to make it as easy as possible, right? A single pane of glass. So you have all your approval processes that are in place, whether is it like based on policies that is dynamically created. You get all your results on your code quality change, your browser performance and matrices, your security scans all in the same place, and that just makes it a lot easier and for you to make an informed decision, right? So again, I know I'm from GitLab, and I'm just going to be biased against my product, but when you are considering a product out there, think about it, right? How difficult is it for your developers? How difficult is it for your team leads to make these sorts of decisions, having all of your 10 or 12 different data points, right? So think about that. All right, so we've seen two things. The third one is this your luggage? Do you pack it yourself, right? I'm not sure about, have you heard about this? I remember a couple of Australian people that went to Bali, and then what happened was that they went to the toilet or something, or the washroom, and then they left their luggage outside. And then once they brought it out to like immigration or so, they found drugs in it. And these Australian tourists said, no, they didn't bring drugs, right? What happened was that these sort of luggages got swapped out, and then they were trying to use those as like drug mules and bring drugs into the country also, right? So nowadays, I'm not sure about Australia, but nowadays what you hear is that did you pack your luggage yourself? Did you leave your luggage lying somewhere else, or is that your luggage to begin with? And what does that mean in terms of delivery, right? So how is software delivered today? So very quickly, you start out from repository. That's where your source code, your package manifest, your Docker files, your infrastructure as code files are. You get the registries. This can be hosted on GitLab today, or you can get it directly from Maven or the different places also. You package them up, and then you put it, whether it's in an S3 bucket or you put it on GitLab as well, inside our LFS folders and all that. And then you build the Docker images, right? So whether is it you host it on AWS or on GitLab, that's also possible today. And then maybe you also reference it from a container registry, right? So in general, right, we make, this is kind of like the idea of how software is developed. It's obviously more complex than that, but in general, that's how it's done. So what I see from this is that there are actually a lot of gaps, or like places where threats can come in, right? First and foremost, you can submit an unauthorized change. You can compromise the source repo. You can build from a modified source, and I think that's kind of like where there was the what do you call it? The SolarWind problem, right? So there was a SolarWind issue last year or the year before, where they actually modified the things and then they were pushing it out to all the different places. Compromise the build process using compromised dependencies, and so on and so forth. Right. Over here, you can see that there are all these different things. So the question is, within the software supply chain, how are we able to do this, or how are we able to make sure that this is clean? Right. With GitLab, oh, okay, I probably did too many animations. Oh, yeah. So the idea behind it is that, I don't want to go into too much detail, but having the proper ways of how you can actually do a separation of duties, how you are able to actually do like sign and verified commits a lot on these cases, and how you are able to separate all of these out in proper ways such that everyone has their own jobs and everyone has their own ways of doing such things. Right, so I will not go into details, but the idea behind it, when you actually do it at the enterprise layer, are some things that you have to consider about when you're looking at this. Right, so separation of duties can also include other tools out there other than GitLab as well, such as like HashiCorp Vault, AWS Secrets Manager, that you might want to actually do that because you give that ability to someone else to handle these things. Right, but in general, these are some of the things that you have to consider. GitLab as well, we are working towards the software supply chain. I did put the directions page here, but generating provenance and attestation is something that we are looking towards. In most of the phases, we are at least level 3, but in other phases, we're at level 2, and we are, planning to get to level 4 on all of the different components with it, right? So you can read that up as you need, as you want, but the idea behind it is this is what we are moving towards, and the industry is moving towards as well, right? So in general, these are some of our partner initiatives with AWS. I just want to quick highlight and mention about these ones here. But I think as a technology partner, we have always been working with AWS for a very long time, and we really like working with them. And we want to continue to do some of these things as well. With that, thank you.
Any questions? Gentleman at the top there in the blue.
Okay, who's me?
Yes.
Okay. I just want to ask you.
Sorry. You're next.
Okay. Just want to ask you a really interesting question. So, what do you think about what's the biggest competitive advantage of GitLab compared with GitHub? Right. We wouldn't want to think like GitLab is a backup option of GitLab, right? Yeah.
Wow, that hurts actually. When you call GitLab a backup option,
No, I don't want to treat it as a backup, right? So we need to think about the competitive advantage over GitHub.
Yeah, I think it'd be difficult to comment about that entirely now. There are differences, and to be honest, I think like the GitHub, the whole ecosystem is it's very strong, and I like it, and there are many people that are with it. I can have a 2-hour presentation with you about that, breaking down all the different things. I just want to, rather than comparison, I think GitLab as a single DevSecOps product out there, considering all the different things that I talked about earlier with regards to like all the security scannings, all the abilities to actually govern and everything like that, I think that's where we are very, very strong on. And I think that not only just GitLab, but a lot of our competitors are either stitching together a bunch of different tools out there to make sure that that happens versus what we do as natively as much as possible.
Okay, I feel like that's a really good checkpoint.
Yeah.
And I think that there's just one word I would say: we're cloud agnostic.
Thank you.
Yep. Definitely. Yeah. All right. So yeah. Okay. I'll not comment too much on that. We can talk about it later.
Okay, of course. Yeah.
There's a gentleman right at the back there in the blue. Back.
Yeah.
With your GitLab environment, you talk about applying security testing. Does your GitLab environment operate the security testing, and who writes the security testing scripts?
All right. Yeah. Just so I'll try to rephrase it, and maybe if I do it wrongly, let me know.
Yeah.
So I think the question is around like security testing as a whole in GitLab. Is it run? Two comments about it in terms of like where is it run, and second thing about it, who maintains it or who controls certain things, right? So as I mentioned in the previous slide, we have 9 different types of scanners that are available, and of course some of them we do actually maintain them ourselves. So for example, our dependency scanners, we use Gymnasium. For example, for fast testing, we use Peach, and these are organizations that we acquired over the different years, and we maintain the databases for that. At the same time, so a lot of these are like the data and like the CVEs and all these kind of things are maintained by us, and also it's open source, so people can contribute in a way. For other types of scanners, say for example container scanning specifically, I mean today's topic was about containers, right? So we do leverage on some of these open source scanners such as Trivy and Gripe, and then we build around these sort of scanners. Right, so some of these sort of scanners we use the open source scanner and we build the rule sets around them. For example, our SAS scanner, we leverage heavily on SamGraph as well. So some of these things, right? So we can have a deeper conversation. For all the 9 different types of scanners, we do have different ways of how we manage them. The next question about runtime. So how do we actually run these things, right? So first and foremost, for our security scanners, they do require a Docker type environment. So whether is it Kubernetes or Docker. And the reason why is first and foremost, it's clean. You can clean it up and then you can throw it away as much as you need. And every time that you run a job, we actually check back against like the Docker say for example Docker Hub where the resources are. If there is a new image with like the new vulnerabilities, we will pull that down and then run it against your project. Does that answer your question in a certain way?
Yeah.
Thank you.
Cool. The gentleman in the brown jacket.
Hi, I just wanted to ask about like developer engagement, and how sort of like you get developers who are working on like features and like already super busy to like engage with security, and like
Yeah.
yeah.
Okay. So developer engagement, right?
Yeah.
To be honest, I don't know so much about that. But one thing I do know is that first and foremost, we pride ourselves. GitLab prides ourselves as an open source company, right? So you can go to our issues page, you can submit a merge request, and we will review that, and then we would do it. If you actually look at our releases page, so we release on the 22nd of every month. We actually promote. And we will write there, this is our top open source developer that actually contributed to our project, and we have inbuilt that particular merge request into the product today. So I think we do embrace the level of open source, and we do embrace the community whenever you actually submit all of these things.
Sorry, what I meant by was like, how do you get developers to actually like look at the results of like the security scans and then actually go and fix them? Because I feel like it's a problem where like.
Oh, how do you get them to do it?
Yeah.
Right. Very good question. Okay, so sorry, I went off tangent completely for that. So first and foremost, I think that's where the governance component comes into place, right? So if you were to look at, like, say for example, the merge request components here, right? So yeah, over here, right? So there is the denial of merge requests, right? So what we have is that we have dynamic like policies where you can actually say if there are critical or high vulnerabilities, you will not allow a merge request to be able to merge, right? So developers who are trying to merge their code in will never be able to merge unless someone from a team lead, a manager, or a person from security approves that change, right? So that creates the onus on the developer to actually fix their code first before they can actually get a code merge. And this whole thing is actually dynamic in that nature. Does that answer your question?
Yeah.
So you need human intervention.
Yes, for certain things like that, yes.
I think we'll take one more question because I think everyone's very thirsty and probably very hungry. Gentleman in the blue shirt behind the camera there. Just you. Yes. Yeah. Yes, you.
Come on down.
Yes.
Just wanted to know, is GitLab platform agnostic, or does it only work with AWS? Can we use it for
tricky question.
for on-premises? Because on our on-premises, we got a very complex development and environment, which I think if your tool, GitLab is platform agnostic, it will be very, very handy.
Yeah. All right. So I, just to rephrase the question, I think pretty simply is GitLab platform agnostic, right? That's the question. We are in an AWS environment, so we love AWS, but at the same time we are platform agnostic. We work in any environment. In fact, when you're talking about like complex environments, so some of the ones, for example, the US Fed, or even for certain, I will not talk about, but we are in a lot of these confidential environments, and we work completely offline, right? You can actually build the whole of GitLab and run GitLab completely offline in that case, and we do support pretty much most of the use cases. And that's probably one of the main reasons why organizations choose us, because our competitors don't work completely offline most of the time for most of their features.
All right, guys. Thank you very much.
Feel free to come personally and ask over the questions, because we've still got some more gifts to swags to give away. But I won't take much of your time, guys. I really do appreciate. We are amazed by the number of people that showed up tonight. So thank you so much. We'll probably see you next month. So my only request with you guys would be, you'll see a big barcode in which we'll collect some of your surveys. It helps us to improve our events every month. So please feel free to scan those and fill up the form. It will only take you about 40 seconds. And without further ado, thank you so much.
Is anyone
Hiring? I would probably relay you towards our delivery manager. Jack. Fair enough. Let's have a conversation about that now. And in the
Even
meantime,
just across the board, what type of role are they looking for?
Entry level DevOps.
DevOps engineer, President Blue. Yes. Sorry. What was it?
cool. Thanks, guys. Those amazing pizzas are waiting. Go have some. Go quench your thirst with some pizzas and beers. Thank you, guys. Thank you.